In this video we will see a new type of exploration by NASA, which makes us question: why is NASA exploring the depths of the oceans? Can understanding the undersea world help unravel the mysteries of outer space? A NASA space mission is taking us to the unexplored depths of our own planet. Subscribe to the channel. Our oceans cover over 70% of the Earth's surface, and over 80% of them remain unexplored. It is often claimed that we know more about the surface of Mars and the Moon than we do about the ocean floor of our own planet. NASA is on a mission to change that. The U.S. Space Agency is exploring the ocean depths for indications of what oceans might look like on other planets, in order to push the boundaries of science and technology in one of the most extreme environments on Earth. It's a quest filled with wonder, danger, and an implosion risk that cannot be overlooked. The hope is that the mission's underwater discoveries will help unravel some of the mysteries of outer space, as well as test some of the equipment and experiments needed for missions elsewhere in the solar system. The depths of Earth's oceans are surprisingly similar to some of the conditions NASA expects to find on other worlds in our solar system. They could even provide clues about where scientists should look for alien life. The deepest parts of Earth's oceans are known as the Hadal Zone. Its name comes from Hades, the Greek god of the underworld, and it is a hostile place that lives up to the name. It consists of deep trenches and channels and extends up to 11 kilometers below the surface of the planet's oceans. Altogether, it represents an area of seabed the size of Australia, and few vehicles can survive a plunge into this dark abyss. It is in the Hadal Zone that NASA scientists, in partnership with the Woods Hole Oceanographic Institute (HOI), in Massachusetts, USA, are trying to explore and probe the limits of life on Earth. Even the language used by scientists for their missions in that region uses terms adopted by space exploration. In recent years, marine biologists have sent several landing modules equipped with sensors and cameras for crash landings on the bottom of the Hadal Zone, where they take measurements. But engineers at NASA's Jet Propulsion Laboratory in Southern California are building a new autonomous underwater vehicle called Orpheus, the English name for the ancient Greek hero who traveled to the underworld and back, to map the most inaccessible depths. Using visual navigation technology similar to that of NASA's Perseverance spacecraft on Mars, Orpheus has highly sensitive cameras to identify rock formations, shells and other seafloor features and produce three-dimensional maps dotted with terrain marks, or rather, seafloor marks. This allows the robot to find its way and recognize places it has already been, but it should also help shed new light on the biodiversity of that hostile environment. Subscribe to the channel. Orpheus is a portal vehicle, says Tim Shank, a deep-sea biologist who is leading HOI's Hadal exploration program. If it works, there's no place in the ocean we can't go. This isn't the first time Shank has tried to reach the dark depths of the Hadal Zone. In 2014, Orpheus' predecessor vehicle, NIBIRU, was sent to the Kermadec Trench, northeast of New Zealand. But the underwater vehicle imploded about 10,000 meters deep, most likely due to immense pressure. After 12 hours, we saw him emerge in small pieces, recalls Shank, adding that the loss of NIBIRU made them rethink how to explore the depths of the seas. About the size of an ATV and weighing around 250 kilograms, Orpheus is designed to be much lighter, smaller and cheaper than previous underwater vehicles. And it should also be more agile and able to enter trenches and vents on the ocean floor that have never been explored before. Europe on Earth. For a long time, marine biologists believed that life in the Hadal Zone was impossible, until, when submersible vehicles began venturing into the region in the first half of the 20th century, it became evident that life could withstand those conditions. But it was still believed at the time that all living organisms were sustained by a food chain ultimately fueled by photosynthesis. Plants, algae and some marine bacteria in surface waters convert the sun's energy into sugars that are stored in their organic matter. This matter is eaten by herbivores, which in turn are eaten by carnivorous animals. NASA scientists were convinced that organisms on the ocean floor survived on dead organic matter, animal carcasses, feces, and the constant fall of other organic debris, or sea snow, floating up and down. But it was believed that there would not be enough food to sustain many sea creatures and that the deeper areas were still too dark and cold for life. This perception of ocean depths would change in 1977, when an American research team launched a remotely operated vehicle 2,440 meters deep into the Pacific Ocean. The vehicle was sent to photograph the hydrothermal vents, where heat from volcanic activity emerges from the ocean floor. To their surprise, the scientists discovered vibrant ecosystems around the vents, teeming with marine organisms such as transparent snailfish and amphipods, crustaceans that look like fleas, that had never been seen before. With this discovery, we found an entirely new form of life on Earth, says Schenk. These animals don't need direct sunlight. They live off the substances that come out of the ocean floor. Scientists were baffled. How do these species manage to survive the overwhelming pressure of the Hadal Zone? The pressure, there, is about 1,000 atmospheres, explains Schenk. It's so strong that an animal's individual cells would be ripped out. Since that first observation in 1977, scientists have discovered that organisms living in the depths have adapted at a cellular level to survive in that region, Schenk said. Hadal Zone creatures such as amphipod crustaceans and snailfish have enzymes called psolites, a word derived from pson, or pressure in Greek, which prevent their proteins and cell membranes from being crushed under extremely high pressure. Psolites fight pressure by increasing the space taken up by proteins inside the body's cells to compensate for the weight of the water around them. It's like putting stakes in a tent, Schenk compares. Discovering organisms that can not only survive but proliferate in this repressive environment raises important questions for biologists looking beyond our planet's realms, such as whether they might also be found in the oceans of other worlds. Beneath the icy surface of one of Jupiter's largest moons, Europa, lies an ocean of salt water. It is believed to be 60,000 to 150,000 meters deep and contains twice as much water as all of Earth's oceans combined. Sunlight does not penetrate Europa's thick ice sheet, which is riddled with fractures and cracks. Beneath the ice crust, the pressure is comparable to that of Earth's Hadal Zone. Here we have Europa on Earth, says Schenk. I don't see how we can explore Europa without first doing the same on Earth. A robot capable of exploring Earth's Hadal Zone could do the same on a frozen moon 628 million kilometers away. The ocean floor is a great test platform for us to develop the technology necessary for a successful mission to the ocean of these worlds, says Russell Smith, an engineer at NASA's Jet Propulsion Laboratory, who is part of the team responsible for the construction, from Morpheus. But a robot operating in outer space or the depths of the ocean needs to be fully autonomous. The robot needs to be able to make decisions, says Smith, adding that the goal is for Orpheus to be able to detect and classify environmental DNA and substances from the water, as well as bring in samples from the ocean floor. Building a robot for the Hadal Zone is an incredible challenge, he says. Orpheus needs to withstand intense pressures and extreme temperatures. Water in the Hadal Zone is just above freezing point, but in hydrothermal vents, temperatures can reach 370 C. Developing a vehicle that can survive is very difficult, says Smith. You need very thick walls to keep the electronic circuitry from getting wet or squashed. Orpheus is partially constructed with syntactic foam, a floating material composed of microscopic glass spheres embedded in epoxy resin. The foam used in Orpheus comes from waste material produced for film director James Cameron's deep-sea Challenger underwater vehicle, which descended to the bottom of the Mariana Trench in the western Pacific Ocean in 2012. As it is totally dark in the depths of the ocean, Orpheus is equipped with a huge flashlight. If the light stays on all the time, It will quickly drain the robot's battery, which would be stranded in the crushing depths. To save energy, Orpheus will go into low-power mode when not taking samples or images, explained Smith. Subscribe to the channel. Mission to the Moon. In 2017, NASA launched the project called Systematic Underwater Analog Exploration of Biogeochemical Sciences, subsea, to bring together the fields of space and ocean exploration. To date, controls have been provided with 2 missions with operators of hydrothermal operations in the Pacific Ocean. An activity from the northern coast of California and back from the seamount, about 30 kilometers off the coast of Hawaii, and northern California, between the California states of Oregon, on the American coast, is believed to be similar to that found on the ocean worlds of Europa and Saturn's moon Enceladus. The whole project was based on discovering in the deep areas of our oceans that take advantage of the efficiency of the exploration of nature that we foresee to find in like Enceladus and affirm the places of the moon and of the outer space. Scientists have used subsea missions to better understand the chemistry and geology of these vents, as well as the life around them. These vents are very innocuous, says Lim. You have to look very closely to see changes in the temperature of the water coming out of the land and interacting with the very cold seawater. Even this isolated action is very important for us to be able to predict how to explore some of these ocean worlds in our solar system. It may be decades before we can send robots to Europa and Enceladus, but the NASA scientists are already applying what they learned from exploring the depths of the ocean to space missions. In 2023, NASA will send a robotic probe to look for frozen water at the south pole of our moon. Known as the Polar Exploration Probe to investigate volatile substances, VIPER, the mission will study ice near the lunar crater, Nobel, in the hope that it can be mined for use as rocket fuel or drinking water. Although it will not operate underwater, a spacecraft walking on the moon will face many of the same technical challenges. We're taking all of subsea's learning and applying it to VIPER, says Lim, who is also the vice lead scientist for the VIPER project. The purpose of the subsea program was to ensure that scientists achieve their research goals under extremely challenging conditions from a technology and communications perspective. From an operational point of view, ocean and space exploration also have many points in common. In these 2 camps, robots are sent to explore treacherous environments that humans cannot reach, supported by remote teams of scientists. But it may also be convenient to train astronauts to control robotic equipment from a moon base in the future. Fewer than 10 scientists went to sea with the subsea mission. They worked with a larger group of colleagues on land. For the VIPER mission, a team will operate the probe on Earth in near real time and will need to analyze data and make decisions very quickly. Efficient communication is key during these missions, says Zara Mrmalek, a social scientist at NASA who helps scientists prepare for exploration in extreme environments. She worked on the subsea and VIPER shows. To explore the ocean depths, scientists have to make decisions all the time, depending on sea conditions, weather and salinity. You'll have less time than planned, explains Mrmalek. It's much more difficult to work in the ocean depths because the conditions are such a challenge for the technology. She points out that, on space missions, communications are extremely limited. In preparation for conditions in outer space, Mrmalek restricted the subsea mission scientists to only communicating with each other once a day. There were no failures. They achieved all of their research goals, she says. Darlene Lim says that, everything we learned working together with the oceanographic community was very valuable, really priceless, in helping us to trust the processes that we are adopting to design our scientific operations for the VIPER. But just as with off-planet missions, exploration of the ocean floor is also allowing humanity to look at Earth in a different way. NASA says its oceanographic explorations have generated thousands of scientific discoveries, but they are also providing other information that could be vital if we are to continue living in a world with healthy oceans. We need to understand our ocean environments if we want to save them, according to Laura Lorenzoni, a scientist in the Biogeochemistry and Ocean Biology program at NASA's Science Mission Directorate. This is critical to life on Earth, and the constant measurements that NASA has taken, and continues to take, are critical to ensuring the sustainable use of our ocean resources, she says. That is, with each step we take towards the exploration of other worlds, we also learn a little more about some of the most unexplored parts of our own blue planet. Don't forget to subscribe to the channel, and activate notifications to receive new videos.